Hello students, welcome back. Let us resume our discussion in section 3. Section 3 was about the law of cosines and its applications. Here's the first application problem. A tunnel is to be built through a mountain, and here's a picture. Estimate the length of a tunnel. I don't like this problem very much because the numbers here are highly unrealistic. You're looking at a mountain and the dimension here are what? 388 feet, 212 feet? What is this? If they are meters, still they're too small, but 388 feet? Come on, what kind of mountain is this? A toy mountain or what? Still, let's forget about the realistic nature or unrealistic nature of the problem, and let's just do this problem for the sake of mathematics application. Alright, c is here, and lowercase c is the quantity we want, right? So c squared is a squared plus b squared minus 2ab cosine of angle c, and that's the law of cosines that we're going to utilize. Alright, and let's put in some numbers. A is opposite of A, so 212 feet, and small b is 388. And then A times B, and then cosine of the angle C, and this is 82.4 degrees. Okay, and all these are coming from the observations, so the estimations. Do this computation and then take the square root, then you're going to get C. So C is going to be the square root of all these. And then punch this into a calculator. Make sure your calculator is set in degree mode. Do your computation, you're going to get the answer. So, what answer are you getting? Well, alright, I'm opening up the answer key here. And this is my computation. I'm getting 416.81 feet. Ridiculous. Ridiculous. But mathematically, it makes perfect sense. I got it from a textbook, but I cannot but wonder, what was the textbook author thinking? Mathematically, it makes a lot of sense though. Next problem. Two tugboats that are 120 feet apart, sorry about the typo, and then pulling a barge like this. Find the angle between the two ropes. Okay, alright, the angle here. This dimension makes a lot more sense. Okay, I like this problem. Oh, by the way, the previous problem was SAS problem. SS and angle in between. This one here is SSS problem. Alright, let's label. So this is angle A. Oops. Okay, there you go. This is angle A, capital A. And then let me label this one as capital B and this one as capital C. Typical. In mathematics, positive direction is counterclockwise, so it's usually better to have counterclockwise A, B, C like this. If you take clockwise, eventually it'll turn out to be okay, but this is the convention. And opposite of A, this is a lowercase small a. And then this one is lowercase c, and that's lowercase b. I'm too embarrassed at my writing here. Not using the writing pad, but with my mouse on a laptop. So let me get out of this drawing mode. Alright, so cosine of capital A is b squared plus c squared minus a squared divided by 2bc. That's the variation from the law of cosines. If you solve for cosine of A, you're going to get that. And then if you're at angle A, then you take inverse cosine of all this. And that's the angle formula. And then you can put in the numbers here. So what numbers do you put in here? And we're going to put in numbers, so let's change this into approximation notation. And then opposite of A, this one is important. That's 120. And the others are not that important, so this one's B, so 212. And the other is 230. And then 212 times 230. Okay, that's a computation. If you label clockwise A, B, C, what difference will it make? Not much, because changing these two, well, addition is commutative, so no problem. Changing these two, again, no problem, because multiplication is commutative. This is important one, subtraction. That's the opposite of the barge. That doesn't go anywhere. Let's take this computation. Inverse cosine, so arc cosine of this quantity. Let me copy and paste this thing here. Just a moment, please. And then let Mathematica run it. It didn't really help. Also, this is going to be a radian mode, so changes to degree. I'm getting 31 point something degrees. 31.12 degrees. 31.2 degrees, excuse me, according to this computation. Let's see. Is that what I get here? Yes, indeed. Alright, typical SSS problem. Next problem. Estimate the distance between the kites. Again, I don't like this problem very much. This time the dimension is ridiculously long. For this boy, holding kites that far away, 420 feet, 380 feet, not 38 feet and 42 feet. I don't know. I mean, mathematically it makes perfect sense, but I don't know. I mean, not as ridiculous as this, of course, but I mean, in this case, nobody will actually build a tunnel, right? You're gonna just turn around. Just what? 300 feet detour? Come on. Okay, alright. Not as ridiculous as part A, but still, I don't like it very much, but mathematically it's okay. So let's go ahead and do this. Stop the playback and try. SAS, just put it into your law of cosines, and then make sure you take the square root in the end. Did you get it? Okay, here we go. Law of cosines, take the square root, in the end we get 210 point something feet. That's the distance between these two kites, according to this picture. Whether it makes sense or not, well, it doesn't make any sense, but theoretically we can consider that kind of problem. Alright, now let's go to part D, and this one I de-emphasize in gray because I thought it may be a bit too hard. Okay, alright, the fisherman leaves the home port and then reaches Egg Island and then reaches Forest Island, and then the fisherman has to come back, And returning bearing and the distance, that's something we have to find out. So, running north 70 degrees west. So, starting from north 7 degrees to the west, and then got to Egg Island. And here, north 10 degrees east. Not drawn up to scale. Doesn't look like this is 10 degrees east. Looks like a lot bigger. Anyway, from this picture, you can figure out the internal angle here. What is it? Let's see. Extend this vertical line and this 70 and then parallel lines. Therefore, this angle here is going to be 70 degrees here. Alright? And internal angle here, the flat angle here add up to 180 degrees. 70 degrees already counted and 10 degrees up there. So what's left over here is going to be 100 degrees. Makes sense? 100 degrees here. So how did you get this 100 degrees? From 180, subtract away 10 and subtract away 70. What's left is 100 degrees. So in the end, what do you get? We have a triangle with information SAS. So we have this triangle here. And let's see. We have 30 miles too light. I can't see anything. 30 miles here, that's one side. And then 50 miles, that's another side. And the angle in between, that's 100 degrees. So this is SAS. Using the law of cosines, we can figure out this angle. Let's say this is capital A. And then the opposite, small a, we can figure it out using the law of cosines. Now, how about the angle here? We have to find out the returning bearing, right? So that's another important piece of information. Right here, this internal angle. You can find out this internal angle through law of cosines. Yes, we have three sides. Assuming we just found out small a from this SAS, now we have SSS. This a value, 30 miles, 50 miles, we can find out the angle. And the final step, finding out the bearing, that's gonna be the hard part. Postpone that and then figure out this length and then this internal angle. Find these out first. Stop the playback and find those. Alright, any progress there? Okay, this picture may be a bit more helpful. This one is drawn up to scale, a bit too big. Let's go to 100%. Alright, A, B, C, alright. I decide to use A over here. Okay, alright, that's where the fisherman is right now. And home port is C, 70, 70, 10, so we have 100 degrees here. And then getting this B using the law of cosines and the angle, internal angle here, you can figure those out. How do you figure out B? Well, SAS and use the law of cosines. In the end, you get 62.6 degrees. No, excuse me, 62.6 miles. All right. And then this angle A here, you can figure that out. You got 28.15 degrees. But then again, what's the bearing? So we have to come south and a bit west. So this is what we need. This angle here, that's the question. Good luck. I'll leave you here. Good luck. Well, Here's the answer.